All right, this is another session where we just talk about anything that we want to talk about. So, Mihail, I hear that you have a question. So, what is the question that you want to ask?
Yeah, I was basically curious to talk to you about software development careers and things like what are the natural progressions in software development careers, just based on your experience, basically. Like, for example, if I work as a developer, so like what are the career steps in my unless I switch to a different background to like become a manager. But what if I don't want to become a manager? I want to stay in software development. So what are the career progression options for me?
Okay, so we'll just start with assuming that you're joining as a developer.
Right? Yes.
Yeah. Now, sometimes even just within developer, there's multiple levels.
Yeah.
There's like Dev 1, Dev 2, Dev 3, so on. Okay. Usually the number means that it gets better. It gets bigger. Yep. So like sometimes this get called out because senior dev, for example. All right. Then oftentimes, so actually it's probably good to mention this is an IC, stands for individual contributor.
Yep.
And this is also an IC, individual contributor as well. Now, the next level up, actually, this might be a good place to start to break into two different paths. Okay. So on the one path, you have what you might get called, like, say, for example, dev lead. Okay. So you can think of this as, like, say, the first level dev supervisor. So they direct the work of developers. Like, I mean, we earlier were talking about, like, say, you as a project manager, you would be working with other people who's in the leadership position to help you to assign tasks. So dev lead would be one of those people. Okay. Now on this side, we're starting to get into architecture. Okay. And in dark, we can just go ahead and call it like honestly, on the architecture side, it's very interesting. There's always all these different terminologies. There's like a tech arc, and then there's like a software architect, and there's a solution architect. I probably should just write the words. And then there's also like data
system
architect. There's even enterprise architect.
Cloud, where is cloud?
And then business architect. I mean, there's all these different type of architectures out there. So architect, in many ways, it's really an overloaded term. I mean, we use it because it's the term that we're familiar with it. But honestly, I really wonder that the true architect in the world, the people who actually create designs for buildings, what they think of us who borrow this term from them. Because they actually had to get licensed. They are professionally licensed. Sure. There's a board saying that, okay, you have to pass exams, whatever. Here's a professional contact you have to follow, and so on and so forth. Whereas we don't. We in the software industry don't have those type of licenses. So, but all these are IC. Okay. And on the dev side, this might also have multiple level. Okay, by a certain point in time, once you go up on the supervisor track, you can call it a dev manager. Okay. So these are the people who hires and fires developers, basically. They actually have resource staff responsibility.
Right.
So, they get to decide whom to hire, and then they can reassign resources to other people. So like the dev lead would be someone, the dev lead would seldom have that hire or fire responsibility. They will get resources from the dev managers who owns the team and say, okay, now, you run this project, basically. You're in charge of this project from a technical perspective. Okay. And then Sorry.
I think very often that would be the role for the person who started their own software development business, and this business is growing, so they hire more software developers, and they have to play that role basically, like development manager. Plus, they have to be business people as well. So like they're wearing.
It's just a title. I mean, you're gonna see these titles in large companies a lot.
Okay.
I mean, they might be called different names, but this is pretty much the progression. Then beyond this, you have the generic company progressions, terms like directors.
Yeah.
You know, if it's a director, it'd be like director of development, for example. Okay, and you might have GM of development, and then you have VP of development.
Right.
Okay, so this is like once you get above this level, basically, these are considered as executives. Director might be considered as a very senior project manager. I mean, it just depends on how the company is organized, right? But these are executive level, basically. And on the architecture side, you basically just progress as IC. Okay. Now, at a certain point, you might then, some companies have tracks that would be something like distinguished engineer. And then they might also have tracks like technical fellow. These are all the potential positions that people open for ICs that are very, very well respected, very impactful, huge thinkers, basically.
And probably these positions are even rare because, like, for example, only a few companies will probably hire people on these positions, and most companies won't because it's just simply too expensive to have them.
I mean, I think that in Microsoft, I remember there's like something like 20 distinguished engineer, something like that. I don't know the actual numbers now. I mean, I left there a long time ago.
So whenever you hear distinguished engineer, it means that it's a technical person with lots of experience, basically, but it's still an individual contributor and not so much of an executive business person.
So what is interesting about at this level, though, is that even though they're still IC, okay, is that they often have a team reporting to them. It's just that it's more like saying that there's a team working for me, working on what I want to work on, but they still focusing on technology stuff. So this team would have complete management capability. So there's people in there who will be, like you might have, say, probably not a VP, but probably like a GM reporting to a distinguished engineer, and that GM has a whole department doing what the distinguished engineer wants to do. So that's a possibility. Okay. And finally, you have CTO. You can CTO is also another one of those positions that's interesting. A lot of times, the CTO position is reserved for the tech co-founder.
Okay.
This term is always funny whenever you talk about co-founders, just because so many people are looking for tech co-founders these days,
and so many things as well.
Right. So, but in large companies, CTO is person who's supposed to be setting the technical direction of the company as a whole. Now, sometimes CTO is one of those positions that it definitely can be technical. Like the person who's running that position, chances are that person is, I mean, let's put it this way: everybody in this whole track right here that we're pointing out should have development experiences.
Yes. Yeah.
Okay. Sometimes you do get people who become a director of development without going through this track. But most of the time, people who go through these progressions do have that experience.
Yeah.
So, and CTO is one of those positions that, depending on the way the company is set up, this person might or might not have management responsibilities. Yeah. It's like sometimes the CTO plays the role of, like, say, VP of development, for example. And in that case, the CTO would have management responsibility. But sometimes the CTO is just going to be a big thinker who's trying to see the technology 5 or 10 years down the road, and hopefully he's right. In that case, this person will be closer to like the distinguished engineer, but You'd be like the head person, the distinguished engineer, so to speak. So, but like say for example, Microsoft, when I was there, they had 3 CTOs, and Bill Gates was had a title called Chief Software Architect. And so he was effectively the actual CTO, but he has 3 other CTOs.
Right.
So
how does CIO fits into it? Like for example,
CIO doesn't fit into. CIO is a bit different. CIO, I mean, what we're talking about here, these are all product. So basically, we're talking about
software position.
Software. We're talking about companies who sells software as a product. These are the product side of the track. Now, CIO is running the IT. So the internal, I mean, IT stands for information technology, but it specifically deals with internal operations. So, for example, running your, like in school, right? School has these mail servers. Have print server. There's a bunch of printers, right? And all of you guys probably have badge, where you can get in. I don't know whether you have badge or not, but like offices I go to have badges. So those are the internal operation stuff, and CIO is in charge of that. And underneath the CIO, there could be GMs, and there could also be GM of development. Actually, and over here it's probably GM of IT, just because under IT, it's going to be more integrated. And over here, you're going to have the PM track, people who's running as a PM, and then you have the BA, and then dev, QA, so on.
Because this doesn't have to be a software company. This could be just about any company. I mean, they could produce cars, and they still need a CIO.
Exactly, right. Yes, it's about the internal operations. What sort of technology you need internally to support you, basically. And then if they actually have development teams, then the development is going to organize based on the way that we described. And some of them, especially on the tech track, can still have a structure that looks like this as well. But it's not going to have some of these are really specific to product companies. These guys are very specific to product companies, basically. And so things like this, these are the product company specific, and these can be shared between IT as well as the product units.
And the product, I remember that just a few years ago, everyone was referring to IT as IT, like everything related to computers was IT, and even developers. Maybe that time there was not so many developers, but still every developer would be called an IT person outside of software.
Well, that's what other companies sees. I mean, we're called the IT industry.
Yeah, the IT industry.
And why are we called the IT industry? Is because we support, we provide software that people use. So no matter what product you create, this product is gonna be used by somebody. It's either used by a consumer or it's gonna be used by business people. And if you use as a business people, then they're gonna use it for internal operations most likely. They might use it to support their whatever, but they're not. Most companies don't resell software. You know what I mean? Software. If they buy software, they buy it for their own use for whatever reason. So they will consider any software companies as an IT provider.
IT provider.
Right. Yeah. Yeah. You have there's different terms for them. There's the ISP, independent software. I think that is provider, independent software provider. Actually, ISV, independent software vendor. ISP is Internet Service Provider. And then you also have SI, system integrator. So consulting companies, contracting companies, offshore companies, falls into this SI bracket. So these guys sells product. And these guys sells solutions.
What would be a typical task for system integrator? Like, for example, what kind of systems do they like? I mean, what's a real world
Salesforce.
task? Mm-hmm. Okay.
Yeah. So Salesforce, CRM, it used to be Siebel before, right? So basically, the CRM, it's a big one where because most companies have sales operation. They need to keep track of their customers.
Yeah.
So a lot of them hires other companies to come in and to try to get a CRM tool integrated with other parts of their system. So like email, for example, they have their own email systems. So they want to integrate a CRM against the email. They also have supply chain, so they want to integrate like SAP together. Try get the logistics of everything. So that way, your customer goes into your fulfillment, and so that you can track the whole customer life cycle, so to speak. Yeah.
Yep.
Yeah. So a system integrator's job is to help you to get all these different pieces of software working together.
Yeah.
Yeah. And sometimes you also have system integrators can also help you produce custom software. Just because you are using packaged software, sometimes the packaged software might not do what you want. So sometimes it can be dealt with via customization. But other times it cannot. You have to actually write a new piece of software and then get them to talk to together like that. So large consulting companies or offshore companies, this is basically they do both. They do custom development as well as they do packaged software development.
I actually know a very similar example from HRM, so like human resource management market, and I know about like 500 products. I mean, like every software developer interested in that area already developed a new HRM system, and they claim that their system is better than others. So I mean, the entry barriers are very low. Obviously, I mean, everyone can create one. Yeah? But those commercially successful enterprises, what they do, they create a product similar to other products, but we also create like a sales force around that product, and we're trying to push it. And one tool I noticed, one competitive tool we're using is that basically we're given that software platform for free, which is not the case with smaller vendors, where they usually try to charge as much as they can, maybe even on the first sale. But these guys are using like a freemium model. So they give it for free, they integrate everything, they just like provide it for the customer, but just the customer pays for additional services, such as like some other things, maybe for integration with existing systems we also pay. So I noticed that there is one company, I think it's called Zendesk, right? Which is doing a lot better than others. I mean, in terms of customer acquisition. And but I also noticed that they provide their software for free, and I mean they don't charge. And most other companies will charge you like even like $99. Like
I think from a human resource one today, the biggest is Workday. I think.
Yep.
Workday is founded by the previous founder of PeopleSoft.
Okay.
So after PeopleSoft was acquired, he left, or maybe he left before. I don't remember the way he went. Then he went and found Workday. So yeah, but all these different pieces of software, there's when you talk about right now we're talking about B2B. So these are enterprise softwares.
Yeah.
And enterprise software, unfortunately, basically, it's pretty much sales driven. And whereas consumer softwares, I mean, there's really not that much of consumer software, but it's marketing driven as well as viral adoption these days. So, Facebook.
Yeah.
What's that? Snapchat.
Yeah. Right. Or even Facebook games. I mean, if you take individual game on Facebook that was successful, was pretty viral. I mean, before it became successful, it was the spamming everyone, literally.
Right. So on the consumer side, there's no way you can do sales because it's just too low of a margin. Because most of them are even just free. and then they try to make it up on via ads or whatever other ways. Right? But on the enterprise side, it's sales driven. You pretty much have to have a sales force to compete.
Yeah.
Because it takes a long time for the enterprise to try to change to or try to use new software, basically.
Actually, I mean, just let me just step away from software development, and I'm just thinking, like my personal feeling about that if the young person now is thinking about career in IT industry, right? I think one legitimate, because everyone will look at software development as a entry option. Like, for example, you wanna become a software engineer, okay, so you can start developing something, but I think there are alternative career options. Like, for example, you can become one of those systems integrators. You can become one of those salespeople selling IT products. I mean, you just need to be in the system and you need to get some experience, but you don't necessarily need to have software development experience. I mean, it's nice, but it's not necessary.
That is true. You can be a salesperson in the IT industry without actually going through the development route. That's definitely true. Same as PM, right? And also BA. Neither of these require, or even QA. None of these requires development. Under QA, there is something called SDET, and that stands for Software Design Engineering Test. So these are devs who act in the QA capacity. But outside of these guys, the dev track and also some automation tester track. You don't need. I mean, the rest of them are not. For the rest of them, technical skills is optional. Yeah, and if we include this more, sales and marketing, that's always the way it is.
Yes.
But I mean, let me put it this way: most of them. It's arguable whether or not technical skills would benefit them. I think the technical skills will definitely benefit you in these roles. When it comes out to these roles, it might not. But when you are in sales, though, what you gotta make sure is that you don't sell stuff that your team cannot deliver.
Yeah.
There's always a tendency that I think that the tendency to overpromise is high. In a sales capacity, because they're not in the role of delivery. They just had to say something to get a customer to buy it, and then any sort of problem that comes out afterwards is not their problem, so to speak. Right. So in sales, it's probably good for them to gain some software development experience. On the marketing side, project might be able to do, some companies might do marketing ahead of the software release, but that's kind of double-edged sword. You release something and then you don't follow up on delivery. You prime the channel, but there's nothing to deliver. So it's the same as overpromise. So it's hard. It's harder to say on the marketing side. I think it probably benefit them less to have software development experience. As the sales guys would benefit more. But definitely it's also optional on the east side. The one where it's not optional, mandatory, is the dev track as well as the QA, the technical QA track. So, and there's also ops. Under ops, there's system admins. Right, and then there's a bunch of other admins. They will also benefit
database admins.
Exactly, DB admins. Now, over this side, they are going to have some scripting experiences. So they're somewhat similar to the SDET in terms of saying that they have to write some code, but they don't have to write a lot of code. But definitely writing code will benefit them. It's like Windows Server. So Microsoft got into the server business by promising that you don't need to have a Unix admin who are known to be, one, expensive, two, very geeky. Right. So Windows Server was so on the premise that anybody can manage them. You don't need someone who's highly technical skill to manage them. But now, as we talked about before, that business specializes. Okay, so these days, Windows servers are not managed by non-technical people; they're managed by Windows admins.
Yes.
Okay.
And that would also apply to Oracle, for example. Like Oracle was also designed as a kind of, I mean, like many people can manage that, not necessarily like Unix administrator.
Right. Special. Well, I mean, honestly, Unix administrator is not going to be capable of managing Oracle.
Right,
you need to have a DBA, a database administrator who specializes in Oracle. I mean, you don't have to specialize in Oracle, but at the very minimum, you gotta have one of the DBA experiences: Oracle, SQL Server, so on. Oracle, Oracle is certainly pretty complex. DB2, these are the three big ones from a management perspective. These days, there's also MySQL, PostgreSQL. These are the open source version equivalent to them. So. And obviously then, these days there's also cloud. So a lot of these management functions are now starting to be extended into cloud. That DBA,
there is also NoSQL database, right? I mean, we see a bit of
NoSQL is also, exactly. NoSQL is also there. There's the Mongo, right? And or some of the other big ones. The bigger ones are probably not what we think. The bigger ones are probably things like Hadoop, and what is that? It's basically
Hadoop,
what people
Apache, and there is also like what is it called? Open. There is an open source project that like it's
Hadoop
is also open source. Yeah, I know.
Hadoop is the Apache open source project for managing the data processing. So
OpenStack, right? I mean, OpenStack is like
OpenStack is on the system admin side. It's not on the database side. So, but anyway, we don't need to be exhaustive here. So, but specialization. This is what people who keeps on asking about, saying, when is the day that we don't need to hire developers anymore? And this is what they don't get. They don't get that people specialize in things. You give people easy tools, and they try to use it, and sooner or later, this tool there will be a particular career track that spins up around these tools. It's like Salesforce was meant to be used by non-technical people, but now you have Salesforce consultants.
Salesforce.
And SQL the whole database used to be like that. SQL was designed so that way anybody can write the queries. But these days you have not just DBAs, but you also have database developers who specialize in writing database code. Right. So this is my unfortunate poke in the hole for people who dreams that there will be one of these days that anybody can write any code and build their own software. Is that it's never gonna happen.
Yeah, it's interesting that a friend of mine recently he is in Brazil and now he is back in Brazil, but he went to Europe for about a year. And he was basically like traveling and he was looking for a job. Maybe I'm not sure how much effort he put into it, but I mean, he was looking for a job and opportunities to work in Europe. And I asked him, he's a database admin, basically, like with a few years of experience, and maybe he doesn't have programming experience or development experience. And I asked him, so is it easy to find a job in Europe for database admin? He said, no, it's not. Actually, there are only a few jobs available. Like it doesn't seem like a very promising career path. And I said, well, what about developers? So I said, oh, for developers, like, basically, like anyone with development experience can easily find a job, he said. So, but not for database admins, which I found quite interesting because even though I understand that the demand for software developers will be a lot higher, but still I would expect a lot of companies looking for database admins.
That's surprising too. But I mean, even if you run all your database in the cloud, you still need to have someone who understands how to balance that. And eventually that person will be called a database admin, just because as your company scales, someone will be dedicated toward that particular job, basically. So I don't know, maybe in Europe they don't do databases. That's possible. But pretty much every company has a database. Every company has multiple databases. Unless it's such a small company that they don't, you know. Any company that doesn't have database these days, chances are that company won't last long, basically. It means they're not tracking all the data they should be tracking. And if they are, someone needs to manage a database.
Right. And that also means that in the future there will be more opportunities, I think, for people with experience with cloud technologies in particular, because almost every company will have to set up their, like, whatever, private cloud or some kind of cloud. And even if they're using like a platform, they still need some people on their end to manage that platform, like platform as a service or like some software as a service in cloud.
Yeah, I mean, even though a lot of these functions can be automated, I mean, that's what a good admin would be doing. A good admin would spend a lot of their time trying to automate any sort of mundane task that they're doing. But even then, you know, we're talking about scale. It's like, you know, in the past, you might need 2 people to manage a single Oracle database. And today, 1 person can manage 100 cloud database. That might be a possibility, but, you know, you certainly hope that these companies that are growing would have 100 databases. So they had to hire 1 DBA to manage that, right?
Yeah, actually, I mean, to me, to a non-expert, it seems like, I mean, there is a lot of future in this, like something as a service platforms, because I think little by little, I mean, they started as like small businesses, basically, as just a test. But now I think the big names are coming into the market and they're basically doing acquisitions, and little by little, they're getting more sophisticated. Now they're offering it to big clients who are paying millions of dollars for those platforms. And I think there will be more demand. I mean, in terms of jobs and career opportunities, it seems like there will be a lot of demand for people with experience working with these cloud technologies. But I cannot really imagine the technical side of this job, because like what kind of skills do you need to be in that job and to be actually employable, even to have a good career? I mean,
let's put it this way. I mean, what's the most popular language in the world today? Java. Right. So when Java
still Java.
Well, yes, still Java. When Java came out, and I mean, Java made huge name for itself around like 1994, something like that. So at that time, how many 10-year experience Java developer do you think you can find?
Maybe about 0, I think.
Yeah, exactly.
I heard some stories where the guy was basically drawn into investment bank like from the street just because he knew a little bit about computers. So they said that, why don't you become our CTO for the IT project that we have? So like pre 1994 times, I think it was possible.
Right, but the way to think about it though is that there's always new technology that comes out. And some people can definitely ride a wave. You might pick the wrong wave to hitch on, but if you pick the right wave, you can literally start with 0 experiences. You know, but obviously you still have to do your job right. I mean, people who did not know how to code Java back then, if they got hired into the Java developer role, they still had to develop and they still had to perform. They had to deliver something, so to continue to keep the job. You know, so but with every sort of new technology that shows up, there's always, you know, a new wave. You know, even not just necessarily a particular technology. You can even just say a broader wave, like we talked about earlier, cloud. And then there's also waves like big data. Big data is, you know, kind of also cloud related, right?
Data analyst and
then IoT, you know, Internet of Things, right? So there's a lot of people who pretend to be data scientists when they're not. I don't want to. I'm not talking about the actual data scientists. I'm talking about people who are riding the wave, but not yet a true data scientist. They're learning on the job because there's a huge demand for such a position. So they jump on the opportunity to learn.
One amazing question that I keep asking myself is that I actually know a lot of scientists, like scientists, and they're working on scientific projects, and almost none of them has incentive to switch to, let's say, IT and become a data scientist, because because I would expect that the person who calls themselves data scientist should have a scientific background. I mean, obviously, they need to be able to do things. But then I realize that
some do have scientist background.
Some do, yeah, but very few.
It's not possible. I mean, basically just that there's not enough. We don't produce enough true scientists to fill all the data scientist roles available. So they had to train people on the, on the job. So you can be a data scientist today if you want to. Yeah. Give yourself 6 months, you can be a data scientist. Basically.
True.
Yeah. So I mean, honestly, there's many jobs like that though. It's like even as we talk about PM, it's a skill that you can learn on the job. I mean, even though that now we're talking about a course, and even most devs. Most devs just have BAs. I mean, Bachelor of Arts. Bachelor degree. This is not the business analyst. This is Bachelor of Arts.
Bachelor of Arts.
Right. Or Bachelor of Science. One of these bachelor degrees.
BS.
Right. BS. I love the BS one. So, you don't need to be you don't need to have a master, or you don't need to have a PhD. To be a developer. And some of them don't even have a college degree. Some of them have a high school degree.
Yeah.
Right? So, in many ways, that's kind of what the war has turned into. Technology kind of liberates the need for you to have advanced degree. And instead of going to school for a long time, you can learn on the job. You can, if you're a self-motivated person, you're willing to put in the effort to learn, then you really can learn on the job, and you can actually make a career out of it. It's totally possible. So a PM definitely don't need a degree from the perspective of a PM. I mean, a lot of PMs do have degrees for other things. If they're not, they didn't come up from the dev background. Chances are that they have some sort of MIS, Management of Information System, or some sort of business degree, or some sort of liberal arts degree.
It's basically the whole new field. If we go into that particular area, I would definitely have a lot of things to add, talking about the gap between like the business skills that we actually need in the industry versus what we actually teach in schools. And I think it's just like it's a huge question in itself.
Well, you're never going to learn PM in school. I mean,
I studied PM. I passed one test in PM a long time ago, but of course it didn't help me at all to actually understand what PM is. Obviously.
Yeah. And same as a BA, this is a business analyst degree. Now, if you have some sort of related business skills, so say for example, if you're a BA, a business analyst for an HR department, then having an HR degree would help because as we talked about before, domain knowledge is king in business analysis. The more domain knowledge that you have, then the more applicable your skills are. So BA can have applicable skills for particular for whatever area they happen to be a BA. Now the thing is that when you are a BA, you also get moved around a lot. Most of the time people don't. Even if you stay as a BA as a career, most people don't stay on a single project for a career, right? They don't stay on a single program. They move around from program to program. So even BA needs to be flexible. They need to be able to pick up new domain knowledges, and so on. So it's still also a skill where you can the best skill is still again the ability to learn, basically, because this is where we're all going. We are going to a place where that the people are going to have to learn on the job, and school. The best thing school can do is to teach you this ability, because no matter what the school is teaching you, chances are, if it's a concrete skill, that skill will become obsolete. And it becomes obsolete very, very quickly. So you have to have the ability to learn, and hopefully the ability to think logically. Reason, basically. It's surprising what. And I don't want to, say bad things about the new students these days, but it certainly makes you wonder whether or not that they go to school to actually learn or not. So
I know. Yeah. I have a bunch of those stories myself. I mean, it's quite
well, you're a professor, so I'm sure that you have lots of stories that you can share.
Yeah, and I think, it's some kind of like we have more and more technology, but actually the ability to learn from this technology is decreasing somehow over years. I would make this kind of conclusion based on my own experience, because people simply often feel lazy just to Google something. Just give me the answer, give me the answer, I will write it in the test paper, but just don't ask me to Google. And it doesn't apply to everyone, of course, but it's increasingly I see this kind of trend.
Well, if you have ability to Google, that's also a skill. That's an ability
that's a skill,
to learn.
Yeah.
Right? So Googling skill is definitely important.
Yeah.
Research skill, basically. The thing about Google is that it's a very fast form of researching, but you still have to know what you're researching on. Yes. And then you still have to be able to analyze the information that you get back from Google. Is that the information that you want, right?
Yeah. And this would be probably off topic, but talking about education system, I would say that one particular thing that I would like to see in our education system and the change in education system is that students need to be more active. Students need to be in charge of their learning. Like students, when they start doing that program, for example, Bachelor of Computer Science, they need to have a goal in mind. They just come to university thinking that, okay, in 4 years I will become like a specialist in computer science. But maybe you won't, unless you actually start working on these projects, demanding more from your professors, asking questions. Even professors will have to change, because if some of them don't fit into this kind of learning environment, then they have to either retire or do something else, or maybe do administrative job, but they shouldn't be teaching computer science if their knowledge is 20 years old or something like that. So I think the students should be more demanding. Then the education system will change.
I agree. And in US, there are a couple colleges that are structured like that. I think Reed is one of them. Another one is Evergreen State. This one is in. So both are in close to where I live. So
okay.
Not that close, but. One is in Washington State, the other one, so that one's closer. The other one is in Oregon, which is not that far from Washington State.
Right.
Yeah, but both of them ask the students to design their curriculum. So you put together, every student is supposed to be putting together their curriculum.
Yeah.
Now, I think Ree is considered a pretty good school. This is where Steve Jobs went, and Evergreen State is not yet that good of a school. But I think a lot of times schools' ratings more has to do with their professor research output, right? Another one has to do with the students' caliber, basically. Yeah. So, why Stanford and Harvard, why are they where they are? Because they have lots of professors who produces a lot of researchers, and then there's a lot of students who would be successful anywhere.
Yeah.
Goes there, right?
Yeah.
So it's more of a function of these two things, So the same students that goes to Stanford would also be really extremely successful if he goes to evergreen state,
for
example.
Definitely. Yeah.
But yeah, I agree with you. I do like to see more students try to be more proactive.
More aggressive basically about their career, because they often take a passive approach of just basically professors given that knowledge to them and they will just write it down, and after that they're ready to find a job. But essentially, I mean, if I'm a business manager, if I'm hiring people, like, I'm not interested in those people who just have a degree and like part-time working experience in McDonald's only. I mean, I would be looking for a person who found like sort of internships, like some kind of projects. They actually participate, they produce some results, and then they came to me, and I'm gonna hire them because I'm interested in their skills, because they do skills. And I think this talk will actually be interesting to students, but also would be interesting to people who may be considering like a career change or maybe some kind of upgrade. And it's very likely that they will look into IT field, right? So something related to cloud or like new technologies, like for example, scientists. I mean, they sometimes have a PhD degree, so maybe they're very capable scientists, but they still can't find a job, or maybe they don't have a teaching job anymore. So maybe for them, the natural career path would be to learn something about data science and actual technologies and try to fit into that field. So they will have to learn about software development. They will have to learn about IT in general and how these things work.
And, I mean, to go back to the point of saying, like, you know, can we fire all developers? You know, for some reason that this is always a topic that comes up everywhere. People just like to say that, well, these days AI is going to take over everything. So developers are therefore no longer needed. You know, you see these questions on Quora a lot, which is really, really funny.
And I've never seen a single developer who would agree that this is gonna happen. I'm also kind of watching. I'm reading the answers, and I'm just like, not a single one developer would say that there is a possibility.
You can say this is a confirmation bias, but I'm pretty certain this won't happen. So. I'll be one of those developers.
Right.
That you talk about.
I understand.
No, but I also have very good reasons, and the biggest reason is specialization.
Yeah.
In businesses, everybody specializes. If you are not, there's only basically a few rules that allows you not to specialize. Basically, if you are a founder, then you can be a generalist. Okay, if you know one of the founders, maybe not a single founder, co-founders. Okay, or if you are the CEO, then you can be a generalist.
Yeah.
All right, but keep in mind, CEO don't get to the position of CEO by being a generalist. CEO gets to the point of CEO by being a specialist in something. Then he finally gets moved in the position. He no longer needs to be a specialist.
Sure.
And why do company grow? Company grow by this thing. It's called this. It's called division of labor. Okay, people who's good. Two generalists. They're both generalists. I just write on G. Okay, their output is gonna be less than two specialists.
Yeah.
One specialized in doing one thing, one specialized in doing nothing. As long as the two of them, whatever they produce, can be combined together, their output is gonna be more than two generalists that knows how to do both things.
Sure.
That's the reason why the assembly lines exists. Assembly lines produces cars faster than each individual people try to, instead of the non-assembly line approach. Basically, the people who are hired knows how to do everything and try to put together a car by themselves. They're gonna produce cars a lot slower than the assembly line workers producing cars. And that's why the companies, as they scale, they will specialize. And that means that anything that you're writing right now, let's just say, for example, if you're in a small company, when you're in a small company, you might have to do sales, you might have to do marketing, you might have to write some code, you might have to do some dev work. But as your company grow, you should pick only the one thing to do, and you should pick the thing that you're best at.
Yeah.
And then you farm out the things that you're not good at, hiring other people to do those work. So that way, the combination of everyone together produces better than if it was just a single person at that time, right? So that alone promises that the dev function, you might write some code in the beginning, but if what you're doing is successful, you're going to farm out that coding capability to someone else, if that's not your strong suit. So as long as people are farming out this thing, then there will be developer roles. Okay, it's as simple as that. And AI is a completely different story. But let's just put it this way: if you have to work with a developer because this role is gonna get farmed out, do you really want to talk to a computer, or do you want to talk to a person?
Well, my answer to this question would be, I still want to talk to a person, but if the computer behaves and acts like a person, then I don't mind talking to a computer, because at some point of time I won't even understand the difference. Maybe the person I'm talking to is actually a computer, and I won't even know
I think that you will find that you probably it will probably be a very long time before we get to that point. But let's just assume if there's a point. But that's not what people think of when they talk about AI. Because here's the thing: is that what people are thinking about when they're talking about AI is that they think this. They think that AI can read your mind.
Yeah.
So you don't have to try to explain what you want to build to people. Because the AI can just look at you, and then they can read your brainwave, and then all of a sudden say, okay, I know exactly what you want. And then AI started producing software.
But the funny thing is, even people cannot do that. I mean, when you communicate, especially across cultures, it's impossible to read someone else's mind. I mean, we can't even expect people to be able to do that. How would AI be able to do that?
Well, I assume AI will be smarter than people. So one of these days, and here's the interesting thing. If AI is smarter than people, then the question is this: why would AI want to work for us?
For people. No.
Right? If AI is smarter than you, why would they want to work for you?
Maybe no.
I mean, do we work for our pets, for example? I mean, actually, some people probably do. The pet owners probably actually do work for their pets. I don't know.
Yeah.
Right.
But yeah, that's a good point.
But if AI is actually truly smarter than human, I think at that time the developer roles are not the only roles that's gonna go away. All the roles in the world will go away. Sales, marketing, business people, none of them are needed. Basically.
Let me just bring a hypothetical example, right? So of how AI can be used, and we'll see if it's feasible or not with current technology. So I'm thinking about lawyers, right? And even though lawyers are humans, obviously they have experience, they know this stuff, they've done it like many times. For them, it's easy. For example, certain tasks are relatively easy. For example, company registration, right? So if you go to a lawyer, they will charge you something like, that's what I heard, like $500, right? And they will just help you. They will just make sure that all the documents that you need to provide are provided. So you signed everywhere. You just basically everything you need that needs to be done is done. So this will take about an hour of work from lawyers, and that's why we are charging you like $500. Right? So now I'm thinking, I mean, this kind of job can be automated. I believe, like, for example, maybe I'm wrong, but I think that this can be automated. Because basically all the questions, like, even though we might have some like inconsistencies, questions, everything, I think all these questions have an answer, and a human with experience will definitely have that answer. So once you collect all those answers, put them into system, make it work together, test it, I think that the system will be able to do that basically at the same level of quality compared to a human at a probably lower cost. And I just think like this is one example, but we might find some other examples. Of course, for more complex tasks, like for example, how to build like a company like Microsoft, I don't think AI can do that at the current level of technology development. So this will take a lot more time and learning, right? But some small tasks can be automated. So
and they have been automated. I mean, the thing is that, you know, I mean, now we're using the term AI really broadly. You know, we're used to saying AI is anything under the sun, and that kind of means that AI is, you know, is not one thing, right? It's like what you're talking about there, Phil. You know, basically, you don't need AI for that. A lot these days, there are a lot of companies that does self-service. You can do a self-registration.
Right.
You can go online. There are places where they just fill out a form saying what you want to say, and then they do all the processing on the back end. It's just straightforward automation, basically, right? So form filling, you know, things like that. These are automation things. But now, what if you have a question? Now, who is going to answer that? Then that's starting to require some sort of intelligence. Let's say, for example, you know, instead of let's just say that for you to try to register a company, it's gonna provide you with 3 operations: traditional Inc., and then also limited liability company, or what do they call it?
S corp.
S corp, right? Also partnership. Now your question is saying, what is the best form of my incorporation? Right? Now, you know, there might be a way for some company to design wizard for you to go through a decision tree to answer a question like that, right? But now, if we can do that, see, we can create something like this, a decision tree for every specific issues that we're dealing with. And then they can potentially give you, say, oh, based on the scenario that you're providing, see, if you're having a bunch of checklists, and this checklist can be exhaustive, then you can truly answer this question. But if you cannot create an exhaustive checklist, and for some questions you cannot create an exhaustive checklist, then your computer cannot respond to that. Your computer cannot respond to a plain open question, because a plain open question would be like, say, you know, for example, what is the meaning of life? Now, how is a computer gonna be able to answer this question to you? It's not gonna they'll give you 2 answers today. They'll give you the answer of 42, or they'll ask you back, say, what do you think
that's
is
a smart
the meaning of life? This is the ELIZA approach.
That's already intelligence.
Right. I mean, a lot of people cannot distinguish this. They think that you know, there are people who talk to ELIZA bots, and they think that hey, this person seems almost like a person, but then underneath it, there's no intelligence whatsoever. So intelligence is a very interesting problem, but I mean, honestly though, I will worry about AI obsoleting all developers as the last job in the world that I worry about. I will worry about AI obsoleting lawyers, doctors, politicians.
Well, perhaps even, I mean, people like travel guides, I think to great extent this could be automated. I mean, we still need a bit of human input, but I think that input could come at the last stage, but all other questions can be actually answered in the process by machine.
Right, and why is that? Because you need developers to continue to improve the AIs.
Yeah.
Right? It's like you have all these AIs that are smart doing things, but these AIs cannot grow themselves. Okay, and it'd be a long time before they can grow themselves because they need input. Who can provide them with the input? And those people who can provide them with the input would be the developers, basically.
Actually, and so I agree with you, but actually this is something that is worth maybe a separate discussion, because I will just put the link at the moment. So we're not going to talk about that today, but there is a very interesting follow-up discussion on that I personally think as a person teaching economics, I always keep thinking about the costs of software development, right? And one interesting topic would be to look at, like, for example, we need to develop more and more and more software. It's obvious. I mean, we need more developers. I agree with that. But at some point of time, the costs of development of that software might actually exceed the budget that we have, not just for one company, but for overall, I think, because governments are already running huge debts on their side. So basically, they cannot help us to the extent we're already helping, basically. So whenever the government says, oh, we need to invest a lot in IT, we need to invest a lot in AI, IoT, right, but I mean, who's gonna get all that money, even if we can?
Well, I think the private industry is doing a good job enough. I mean, you know, the thing is that, is there a value to have more AI? If there is, then someone is gonna look at that and say, this has a money-making potential, so therefore I want to invest in it. But if it turns out to be a bust, so I don't know if you know this, but AI, there was an AI boom, kind of like the dot-com days. But this was back in the 80s.
I know.
Okay. So in the 80s, there was, you know, AI was the big thing back then. And then it disappeared. Just because it could not deliver what it promised. So there was no value. There's no end value at the end. So, but AI technology kind of doesn't go away. Technology just gets repackaged. Because once you develop it, someone can acquire for cheaply. It got overvalued. It got overexpended. So, you know, they try to sell it out for loss. Then someone acquire that technology. They can try to see if they can grow this technology, take it in a different direction, and try to make money with it. And today, AI, the term AI is coming back. I don't know why this term is coming back, to be honest, because the AI today is definitely not what we are truly thinking of as AI. It's just a marketing term. This is to me, AI is the biggest FUD of the last century, basically. It's one of those things that people always talk about because they always imagine this Terminator style AI. That Skynet is going to launch all the nuclear missiles against the world and everybody. They always want to take over the world. I mean, it's because I have no idea why AI want to take over the world.
Well, the interesting aspect is that in Japan, AI and IoT is not currently, right now, at this particular moment, it's not just as a buzzword. It's actually the government policy. I mean, you just switch on your TV, and if you watch business programs, they always talk about like companies investing in that IoT, like AI, like what AI can do. They show all these robots, they show like this and that. But the first question I will ask these people is that, do you actually understand what IoT is? I mean, like you're showing some like futuristic things, but I mean, like what is IoT? I mean, maybe you might not even actually be able to explain what IoT is. Is it a real thing? Is it some kind of like a mystery? Is it? But the government is obviously setting priorities. Like we are trying to invest money into it. We are trying to support businesses investing into it. But I have a question. I mean, I'm not sure that the government actually understands what we're investing into.
Maybe not. But I mean, this is the reason why that you want the private industry to do it. So private industries, even private industry can get it wrong, but private industries have their own skin in the game when they get it wrong. Government doesn't have the skin in the game when they get it wrong. So it's just, I mean, it's fine. This is obviously we can talk about this for a long time, so we don't need to rat hole on the whole AI stuff. But I'm pretty certain that the developers will be one of the last jobs that gets obsoleted by AI. Other jobs are much more in danger.
And this is something that I found from my own research when I was basically thinking about learning development skills myself. And I haven't given up on this idea. I'm learning a little bit like here and there, but I'm not committed to it 100%. So I'm just learning it as a part of overall learning. And one thing I found is that there is too much emphasis. I mean, it's possible to become a self-learned developer. There is no question about it. But I think the only way to do so effectively would be to actually working on projects. While what is offered currently is more like that huge poster, like let's learn to code, right? So, oh yeah, let's learn to code. Let's even like get government funding to help us learn to code. Like, I don't see the
maybe I should offer that as a service
yeah.
and get some government fundings. Hello, are you still there?
Think and learn. Yeah.
I think you were disconnected there for a little bit. Okay.
Oh, really? Yeah. Maybe it's a Skype problem. So, personally, yeah. I don't see the link between learning to code and becoming a software developer. I mean, there is a link, obviously, but I don't see the direct link. I think that becoming a software developer is a process. You need to work on different projects. You need to learn different languages. You need to understand how software is developed, and that will make you a software developer, even a junior one. Right? But there is a common perception that, okay, you do that tutorial, this tutorial, you read this book about Java, like there is a new book about Java, and you become a software developer. I mean, how can you actually become one? I don't think so. I think it's just...
But you can become one if you work on the project.
Yeah.
If you try to build something, right? I mean, how much of a developer you become depends on what projects that you build. But start with a simple project. Gemoji, this one. I mean, honestly, if you want, you can try to do it. Although this one isn't structured to teach you from development from scratch.
Yeah. It's going to be a bit challenging. Yeah.
Right, but start with a simple project. Start with Hello World. This is basically what every software developer starts from. You just add one function at a time, and then just recompile it, and then just keep on watching it grow. And then, with every single function that you add, it's going to take you step by step toward a bigger and bigger application. Bigger tool that you might find useful yourself, someone else might find useful, right? I mean, this is basically the process that you're talking about, and then you just have to repeat this process by 10,000 times. 10,000 times. I'm pretty sure I have compiled 10,000 times in my career, probably more than that.
Right. But then that's correct. But I'm just thinking that basically, in addition to technical skills, that we're now focusing on technical skills, but you also need to think about things like cross-platform compatibility, right? So like you're writing something for Android now, how does it work on iOS? It might not even work on iOS, so you might have actually to learn that skill. Then the other thing is like working on just personal project and just adding code little by little. It's not the same as working on a commercial project, having deadlines, having a manager, like project manager, and working under them.
Those are all true. Those are all very true. But at the end of the day, it's the same as anything. It's how do you solve problems, basically. Cross-platform is a problem. So how do you solve that problem? And how do you restructure your project so that way that problem is solved?
Right.
And due date is a problem. Now, obviously you have to be able to simulate it somehow if you're not on a project that have due dates, right? And that can be challenging for some people. But again, though all these are problems. So how do you overcome the problems? How do you solve them? And if you can solve them, then you've succeeded. You've grown. You're now at the next level. Maybe not next full level, but you're a little bit higher than where you were before, in terms of skills, experiences, maturity, capability. So, I mean, just like language, you had to learn how to say one word at a time. Then you figure out to form a sentence. Then you figure out how to understand what people are saying. Then you figure out how to reply.
Yeah, and just one thing I would add from my perspective is that only when you focus only on like sentences, if you focus only on vocabulary, then you will probably continue learning that language like forever as a process, as a hobby. But to become like fluent, or like in this case, to become a experienced software developer, yeah. So you probably need to work on like real life projects. You need to actually apply that code and skills. You need to learn things that you probably won't find in books or tutorials, and that will definitely be at least half of what you actually need to learn to become a software developer. This is just my personal vision of it. And same thing applies to language. So through actual communication, you are actually understanding things that you will never understand just when you're learning vocabulary. So if you're learning vocabulary, it's one thing, but sort of actual communication has some magic to it. And that's basically, that magic is not really taught, it's just learned through experience. And I think the same thing is true for software development.
That's true. That's very true.
Mm-hmm.
Okay.
Yeah.
Okay. Probably a good place to wrap up as anything.
Yeah.
Is there anything else that you would like to talk about?
Yeah, I think it was a good talk.
Okay. All right then. In that case, I will stop the recording.